Alright, so we're here for lesson 22's checkpoint. We're going to start with question 10. Which value is equivalent to cosine of 30 degrees? And in your notes, if you don't have this jotted down, I would write it in that complementary angles have a relationship between sine and cosine. So cosine of 30 degrees would equal sine of its complementary angle. So 90 minus 30 is 60. And so cosine of 30 is equal to 60 degrees. So if you don't have complementary angles in your notes, please jot that down, as well as that sine and cosine have a relationship with complementary angles. So sine of 60. Alright, question 8. What is the cosine of 135 degrees? Alright, I highly recommend that you memorize the first quadrant of the unit circle. So at 0 degrees or 360 degrees, what is the value of cosine? The coordinates would be 1, 0. At 30 degrees, the coordinates would be the square root of 3/2, 1/2. At 45 degrees, we have the square root of 2/2 and the square root of 2/2. At 60 degrees, we have 1/2 and the square root of 3/2. And then at 90 degrees, the coordinates would be 0, 1. Now the reason why I'm recommending you memorize just the first quadrant is because each of the following quadrants can be made by reflecting these points. So, for example, if I wanted to know 180 degrees, I would reflect this point, 180 degrees, and it would be, since it's in quadrant 2 and we're headed to the left, it would be -1, 0. And similarly, if I wanted to reflect this point over here, which would be at 150, because this is 30 degrees, and if I were to reflect it, this reference angle would still be 30, so I took 30 from 150. But since now we're going to the left, the coordinates would be negative square root of 3/2, 1/2. And then if I wanted to reflect this point, the 45 degree reference angle one, it would be at 135, because 45 minus, since I'm going back towards the 90, I know I'm going to subtract 45 from 180. So this would be the 135 degrees. I started from 0 degrees going this way. If I started from 180 degrees, I subtracted 45 to get 135. And since we're headed to the left, these coordinates will stay the same. That length didn't change. The radius didn't change. So the only change is in the direction, which is now we're going to the left, which is a negative x coordinate. So we have negative square root of 2 halves, square root of 2 halves, And then if I were to reflect this point, the reference angle of 60, I know I would be at, if I took 60 from 180, that would leave me with, sorry, if I took 60 from 180, that would leave me with 120. And since now we're going to the left, that the distance from the center to this point didn't change. It's a length of 1. So this is still a length of 1 because we had a reflection. The sign to indicate that it's in this quadrant, though, is now that it's going to be a negative 1/2, comma, square root of 3/2. So in quadrant 2, we have negative cosines and positive sines. And then if we wanted to build quadrant 3, we would just remember that since we're going left and down, that it would be negative cosine and negative sine. So all of these coordinates would now be negative. And so this one would be a reflection of our 30-degree angle. So what's 180 plus 30? That's 210. So at 210 degrees, it'd be negative square root of 3/2, negative 1/2. We would reflect this one, which was our reference angle of 45 degrees. And if we add 45 to 180, it would give us 225. And since we're now going to the left and down, both cosine and sine are negative, so it'd be negative square root of 2/2, square root of 2/2. Or you could think from quadrant 1, this would still be 180 degree rotation, 180 degrees, and then 180 degrees here. Again, so the coordinates for this one would be negative 1/2, negative square root of 3/2. And since this one was a reference angle of 60 degrees, I'm going to add 60 to 180, which is going to give us 240. And then this one is 270, which will be 0. Since we can't have 0 as neutral, there's no sign associated with 0, and we would have negative 1. So that's how you would build quadrant 3. And then quadrant 4, cosine is positive since we're to the right, and cosine is our x value. And sine would be negative since we are going down, and sine is our y coordinate. So then if I were to take my 30-degree reference angle and reflect it about this x-axis, it would land right here. And it would be square root of 3/2 and negative 1/2. And if I were to reflect my 45 degrees reference angle, the point made by the reference angle of 45 degrees, it would land right here, and it would be negative square root of 2/2, negative square root of 2/2. And then again, we would reflect this one about the x-axis, which gives us 1/2 and negative square root of 3/2. So you can create the entire unit circle by just memorizing this first quadrant and what your reference angles are when associated to the coordinates. So I highly recommend that, especially if you're going on in higher math. classes, the unit circle comes in handy. So what is the cosine of 135? Well, 135 is in quadrant 2. The reference angle is 45 degrees. The reason I know that is because 30 and 60 end in a 0, and any of their reference angles would end in 0 as well. And 45 is the only one that ends in a 5. So we have that. Cosine is our x-coordinate. So since it's going to the left, I know it's going to be negative, and it's going to be negative square root of 2 halves. Question 7, what is the sine of 150 degrees? So I would strongly encourage you to try and make the unit circle. And remember that sine is your y-coordinate in the unit circle. Question 6. A right triangle in which one acute angle is a reference angle for 115 degrees. For a 115 degree angle in standing position intersects the unit circle at coordinates negative 0.423 and 0.906. What is the approximate value of cosine of 115 degrees? Since we know that on the unit circle, and that this intersects the unit circle, that means it's on that unit circle. So if you were to visualize the unit circle, 115 degrees, right here-ish. So that's what these coordinates are. Negative 0.423, comma 0.906. And if you didn't remember that that cosine of 15 degrees is the x-coordinate, you can always draw a reference triangle. So bring it down to the x-axis with a 90 degrees, and then you would know that this distance right here is 0.906, and the x-coordinate, the x distance is negative 0.423. And then you can use your reference angle right here. And we have opposite side from our angle, the adjacent side, and the hypotenuse. And in the unit circle, the reason why it's called a unit is because it's 1. So then cosine is adjacent, the ratio of, so the cosine of our angle is equal to the ratio of our adjacent side length over our hypotenuse, which is equal to the adjacent side length is negative 0.423 over our hypotenuse is 1, and negative anything divided by 1 remains the same. It's like saying you have 5 apples, now put them into one group. How many apples do you have? You still have 5 apples in one group. You didn't have to separate them. So our answer is negative 0.423. And that's just how you can do it if you forgot the relationship between the x-coordinate and cosine. Alright, what is the cosine of 240 degrees? This would be a unit circle question. Evaluate sine inverse of negative 1/2 for the angles between 0 degrees and 360 degrees. My son's talking in the background. You hear him. So this is giving us the coordinate. So I'm thinking back in my mind, okay, where does the where is the y coordinate -1/2 in the unit circle between 0 and 360 degrees? And a clue here is, since this is the y coordinate and it's negative, I know it's going to be in quadrant 3 and quadrant 4. So then I think back to myself, okay, the 30, 60, 90 triangle or reference angles are the ones that have 1/2 in them. So if I were to just sketch these points, this would be a 30 degree, or this would, or it would be the 210, 30 and 180. So at 210 degrees, now this is how I remember it. 30 is the smallest angle, so the side opposite 30 is going to be the smallest side. And in a 30, 60, 90 triangle, you have the side measurements of 1/2, the square root of 3/2, and 1. And the square root of 3/2 is greater than 1. So then I know that the y is 1/2 and the x coordinate is the square root of 3/2. Sorry, the way I remember it is that the order is 1/2, square root of 3/2, and 1. And the reason I know square root of 3/2 is larger than 1/2 is because the square root of 3 is a number that's larger than 1. And so I know that for 210 degrees, the sine would be -1/2 and square root of 3. So inverse functions are asking for the angle at which this ratio occurs at. So the ratio at which it's -1/2 for sine happens at 210 degrees. And since there's two quadrants where sine is negative in, there's going to be two angles. And I'm going to rotate that since I know that's the, I'm going to reflect it since I know that this is a distance and reflections preserve distances. So if I reflected my 30-degree reference angle, that distance would still be -1/2 on the y, going down for the y, and the x axis, or the distance in the x direction, would still be square root of 3/2. This one should be negative. So I know the reference angle is 30 degrees, and so the quickest way for me to figure out what this angle is would be 360 minus 30, which is 330. Alright, again, question 3 is very similar to question 4. You want to know what angle does the ratio of square root of 3/2 happen for cosine, which is our x coordinate on the unit circle. And your quote is by Plato. He said, never discourage anyone who continually makes progress, no matter how slow.